And hello, welcome to this video. Okay, so in this video, I want to talk about starting with NI-DAQmx. Okay, NI-DAQmx, there's a capability to use Python. So that means I can use Python with some National Instrument software. Okay, okay, it uses an API for interacting with the DAQ, okay, without using LabVIEW so-called directly. However, the software is still pretty much given by National Instruments. So suppose you want to get started with learning how to use this, and I assume you already installed the NI-DAQmx and you know how to install it. Okay, next step is, well, how would you want to get yourself familiarized? How do you get yourself familiarized with this Python? Okay, NI-DAQmx Python. You may not. Okay, how do you get yourself familiar? And the thing is that if you are trying to work from home, the DAQ may not be with you. Okay, in this era of coronavirus, it's very hard. I mean, sometimes it's hard to go to work and access the hardware you need to access. So how then do you start learning about NI-DAQmx? So this video is going to talk about creating virtual DAQs. Okay, so let's get started. Okay, virtual DAQs. So again, the story is that you already heard it before. Okay, I think I'll not repeat it. So let's see how to get started with virtual DAQs and virtual devices. Okay, you can look at some videos here. It's called DAQ without hardware, LabVIEW programming, and the documentation here is creating simulated NI-DAQmx devices in NI-MAX. So when you make a virtual device, a National Instruments device inside your inside NI-MAX, the Explorer. So this is what NI-MAX looks like. This of course mine's at home now. There's no like hardware to work with. Well, if you want to practice Python, if you want to practice Python or what do you call it? You want to practice Python or you want to practice using the Python modules at home, you can start with making simulated NI-DAQmx devices. So the procedure you can find out over here. I will kind of follow with this tutorial over here. So I'm going to create a simulated device. So to create a simulated device, you need to go into your main interface. Under network devices, you just right click. Okay, normally you have to go and click find network NI-DAQmx devices, but we don't want to do that now. we want to create a new device. Okay, and then we can go and click simulated NI-DAQmx device or modular instrument. So this is how we create a virtual NI-DAQmx device. And what exactly are we creating? Okay, there are lots of things here to choose from. You may need to know what the device number you are picking represents. Some device numbers pertain to, let's say, thermocouples, flow meters, whatever. Not all the devices are the same. So let's just follow this tutorial here. Okay, I'm going to go for the NI compact DAQ chassis 9132. So I'm just going to follow the tutorial blindly, so to speak. It's the compact DAQ chassis NI CDAQ 9132. Okay, that will create this, and inside the tutorial, of course, this is the chassis. We are not over here. We cannot use this thing here to like so-called simulate measurement of voltage or temperature or whatever you want yet. We will actually need to add some modules. So for this, we need to add C series modules. So I'm just going to follow the instructions here and configure simulated CDAQ chassis. So let's take a look at the CDAQ chassis, and we will configure it. Okay, there are 4 slots here, And what then do we fill it with? Okay, I'm just going to copy whatever's the tutorial, 9201, 9203, 9202 and 9269. Okay, I don't know what these are, I'm just following the tutorial. 9201, 9202, 9203 and 9269. We will find out soon enough what these things are. I'm just going to click OK, and all of a sudden we have 4 modules here. Okay, you can of course rename these modules to whatever you want. Maybe I can just call this my DAQ, and then it will just be called my DAQ over here, and I can just click save, and then the the NI-DAQ9132 is just called my DAQ. So I can call this, well, we can call this whatever we want, module A, and then we'll just click save. This is how you rename module B, save module C. Of course, I can do module D here. And then I'll just click save. Save. Looks like I have to save tab by tab. So this is how you can do the renaming. Okay, so that is creating a virtual DAQ, but it's not really putting out any data just yet, right? So the next part we're going to talk about is using DAQs to put out the data, visualizing, seeing data with DAQs. Okay, seeing data with the DAQ. You want it to simulate some signal, and of course you want it to be able to see it to kind of ascertain or find out that it's working, right? So that's what you do. Okay, so this is usually found in your next steps. It's called create tasks for NI measurement and automation explorer, NIDAQmx. So this is the website. I will put it in the description. Okay, so without reading all of this, I'll just bring you to what you're supposed to do. Okay, so why is there a task terminology? So basically, if you have all your DAQ modules, well, they're not doing any work yet. You want to tell them to quickly collect temperature samples or voltage samples, for example. Right, you say, hey, DAQ, please collect some data. So you're giving them a task. So this is what creating tasks is about. So I'm going to create a task, and the task I give it is to acquire signals. Now, this will be, you'll not be acquiring a real signal, you'll be acquiring a simulated signal, which is usually a sine signal. You can go and click analog input, and there are a number of things you can select from. You have force, you have pressure, torque, all of these things here, acceleration, pressure, position, resistance, etc, etc. Under temperature, there are a fair bit of things as well. The most basic is voltage, but I will just try to use thermocouples. Now you can see that for thermocouples, not all the modules are supported. Only 9201 and 9202 are supported. They call it module A and module B, which I can pretty much rename it as a thermocouple A and B. Yeah. And then, of course, if you want to check out what module what 9201 and 9202 are, you can check it out later. But I'm just going to click module A. I'm going to click channel 0. Okay, module A has 8 channels here from 0 to 7, so that's 8 channels. Module B has 15 or 16 channels. So I'm just going to click the first channel of module A, and I'll say I want to enter the name for this. This task is called module A temperature reading. Okay, and then I'll just click finish. Okay, if you're not too sure what's going on, don't worry, it's quite normal. So okay, you are then brought to this table where you have this thing, two things here, 2 columns here. One is called the channel column and one is called the value column. The temperature is for now at 0, So what are you supposed to do with it? How can you take a look at a real-time signal? So normally what you need to do is to click run. Okay, when you click run, you will be able to see the temperature sort of fluctuating between like 24 and something else. Okay, so I can change this to maybe 60. Yeah, and then you can see that the value goes somewhere close to 60. I can change it back to 25, and then the value here changes to 25. And I'm going to stop. So this is how you sort of have the temperature sort of reading go. Right? If you want to take a look at a graph, you can look at this thing called under acquisition mode, under timing settings over here, bottom left side of this table. You can look at acquisition mode. You can, instead of going towards one sample on demand, you can go and look at continuous samples. Okay, continuous samples. Okay, so continuous samples, you will be given two options under this. One is the number of samples to read. The other is the rate in hertz. So what's actually going on here? Okay, but before we start anything, let's just click the run button to see what happens. So there is literally nothing happening except the temperature reading is just constant at 25. I can change it back to a constant at 60. Okay, change it back to a constant at 25. I can change the source to something like a channel, and I will click run. Oopsie. So I'm just fiddling around with the settings here, and it just shows some kind of error. Okay. And let's try the built-in thing and start running. Oh, you have to save first. Task currently has an error. Requested value is not supported for this property. Okay. Built-in is not supported, so just change it to constant. Then we'll click run. Okay, so I mean it's not very interesting here. Nothing very interesting here. Alright, so what's going on? Okay, let me stop. Let me explain some things a little bit. There's a thermocouple type here. I won't go into detail. I'm not. As of now, I'm not really even sure what this is yet. I'm not really expert at thermocouples. But of course, you can Google and do some research on this. As of now, as of this recording of this video, I'm not that sure. But okay, if you normally if you want to change, if you take a look at this signal here, you can see that well, I can alter the signal by playing around with the stuff in these two boxes here, the CJC source and the CJC value. What you saw me doing just now is play around with this CJC value. Okay, and if you want to change the way the graph looks, okay, you can change this acquisition mode from one sample on demand, where you will only see one value here. So if you click run, and then it will give you around 75, the value of 75 with some noise here and there. So that's one sample on demand, which will change the so-called display of this thing. Or you can go and click on continuous samples, where you're able to see a graph. Okay, so so the continuous samples is the way you can take a look at if you want to see graphs. Okay, what's this samples to read and rate? Okay, let's say well, let's start with the easier one first. What is rate? Rate is how many samples you take per unit time. That's why the thing here is in hertz. So rate is 1000 hertz or 1 kilohertz. That means it takes about 1000 samples per second. Okay, it takes about 1000 samples per second. Okay, then what is samples to read? Okay, samples to read is how many samples do you take before displaying it on the graph. So if I read 1000 samples per second in your rate, and over here I stipulate that I say that I want to read only 100 samples, then how long am I actually reading samples for? Then I'll only be reading samples for 0.1 seconds. So you can see the time graph here from 0 to 0.999 something, that's essentially 0.1. Okay, I'm only reading samples for like 0.1 seconds at a time. So if I click run continuously from 0 to 0.1, there will be something over here. So let me change to 40. Okay, so it will change to 40, and I will stop. If I change the samples to read to 500, for example, okay, you will see the time axis actually goes longer. So I'll save, and let's run again. So you can see the y-axis kind of changes as well. Okay, so I can change to 25. So the thing kind of instantly changes to 25. All right. If I want to have maybe 4000 samples to read at 1000 samples per second, the graph will then take 4 seconds to refresh. So if I change to 25, I change to 35, I change to 45. Okay, so after 4 seconds, you should see the graph actually change. Yeah, so you see the graph changes a lot slower. Okay, slower than before. So can change this to 75. So the next 4 seconds, the graph should have a sudden jump towards 75. And now you see we are at 75, I guess, Celsius, right? So yeah, this is how you kind of play around with the signal that's being collected virtually with this thermocouple. Alright, so there are other things you can play around with as well. Let's see how much time we have. Okay, you can also play with voltage. This is a very common thing to play with. So I can actually have a voltage thing here, and both module A and B are able to play with voltage. I can do channel 1, and yeah, here we'll have voltage, and terminal configuration you can just leave it as differential. Custom scaling, you don't want anything. Okay, and instead of having 4K samples to read, I'll just put 500 samples to read at 2 kilohertz of sampling rate. So voltage, normally what you'll see is a sine wave output. Okay, scaled units is in volts. Then I can just click run. So you will see two things down here. You will see one is a what do you call that? One is a alternating so-called, I guess, AC voltage going up and down between -10 and 10, which you can play here. You can change this to 30 if you want. So this thing will actually give an error. So -30 and 30. And let's save. I'll just click run. Oh, requested value is not. Oh, I see. So what it says is that the maximum voltage cannot exceed 10 volts. Okay, so I can't play beyond 10 volts for some reason. So I can change it to -5 and 5. Okay, so just read the error messages. Oops. Okay, so you can see that the voltage is pretty much a sine wave with some noise, and the temperature thing is just constant. There's nothing much that you can do there. Yep. So we'll run. Okay, so we can change this to 50. Okay, and if you want to change this to 0, we can. Then you can see the sine wave going up and down. It's a little bit maybe 20 is easier to see, but yeah, you'll see the sine wave going up and down. every 0.25 seconds. If you change this to 2000 samples to read, you should be able to see one full sine, or at least a bigger version of a full sine waveform, because you're taking 1 second at a time. So every second this voltage sine wave is changing. So yeah, that's all. I showed you how to create virtual instruments, so to speak, or at least a virtual DAQ with virtual data. And with that, you are able to then, I guess, play around with either LabVIEW or Python code to be able to connect to these virtual DAQ devices and do stuff with it. So that should help us get a little bit more familiar with the API for Python if we don't have DAQs at home to practice on. Right? And that is the whole purpose, right? So that's the whole purpose of this. It says if you want to understand functionality and test hardware capabilities without hardware being physically present, a simulated NI-DAQmx device can replicate properties of this. Okay. Okay. So okay, I think that is more or less it. Okay, so that is more or less it. I will stop the video and I will see you next time. Alright, thanks for watching.